Hi everyone and welcome to Flipping Heck Business, Flip Learning for AQA A-Level Business Studies. This is Unit 2, video number 5. So this is the Management, Leadership and Decision Making unit. Today we are going to be looking at decision trees. So you need to know what is a decision tree, how to calculate expected values, calculating net gain, and then assessing the value of the decision tree as well. And of course, you need to know how to actually write them. So this links very closely with things such as business objectives, scientific decision making, hunch decision making, obviously as well. Any kind of like potential sales forecasting that might be coming up, such as in the financial unit, and then also investment appraisal, which again is part of finance. So first of all, what is a decision tree? Well, put simply, it is a method that companies use to actually oversimplify or to simplify decision-making process. Now, it applies logic to basic decision-making. It can be used as a visual aid and structure because, I mean, like, not every manager is going to be able to look at the maths of a decision and just be able to make, right, okay, so that is a good decision or not. And also, it helps to solve any subsequent like decision problems. It enables businesses to quantify decision making. So in other words, turn it into numbers, which makes it a little bit easier to actually decide on. It's useful when outcomes are a bit uncertain. So you're not actually sure, okay, so should we go this way? Should we go another? Especially when it looks at like any kind of potential probability scales. Places numerical value on likely potential outcomes, so again it makes it a bit easier to decide, and it allows comparisons of different possibilities as well. Okay, so when you're trying to actually write a decision tree and construct a decision tree, then it should always start with a square. Now the square represents the decision to be made. From the square we get the first choice or the first option. And this would be as an arrow, try and have it coming off the corner if you can. If not, then like halfway through, like, you know, down the middle of it. So somewhere, say, around here. Right? And that will have option 1 at the top, so state what it actually is. And then it would have the cost underneath. And don't forget, the cost is a negative, so you should put it into brackets. Now, this option goes to your outcome. So straight away we've got our outcomes there. Now outcome is always a circle, so it should always go square, arrow, circle. From there we've got outcome A. Now this is usually like, you know, high probability or like success. Success is a very common one. And then underneath that it'll say probability underneath, which will always be 0 point something, so 0 point whatever figure. And then you get your results. So that could be like higher wages, or it could be higher salary. Not salary, sorry. It could be higher revenue, or it could be higher profit. And then you would have a second outcome. Now there can actually be more. There can be 3 or 4, but you would put that as outcome B. So again, you would state it. So if the top one was success, the bottom one would be failure. If it was high, it would be low. Right? And again, probability there. Now the probabilities should always add up to 1. So if you've got 0.2 probability of success, then it would be a 0.8 probability of failure. Right? So there should always be that. Now, if it's as a percentage, like say you get a 60% return, then again, all you have to do is just convert that into a point figure. So 60% would become 0.6. Right? And again, you would have the result at the end. Now, you would do the same then for option 2. So you can see how it comes out of the middle, it comes out of the side. So you've got option 2 with cost, you've got outcome, again the probabilities and the result. And then there would always be like really a line which is do nothing. So do nothing usually is like, well, you know, everything will continue. Now from there, you can see that we've actually got like a breakdown, so we've still got those. Now, once you've actually got all of this written, so you can take this from the questions and then you can just sort of fill in the blanks as you go through. So what you might have is like the options, and then you would have outcome A probability, but not outcome B's probability, which again you can just work out because it should always add up to 1.0. Or it could like give you the total result and not the just one of the works. So again, you would have to try and work it out. Now from here, you need to work out the EV, which is the expected value. So expected value is the result times the probability. So nice and simple. Now, I would recommend trying to just sort of keep it nice and neat. You've got the result written already. Just move that probability over so that it goes result times probability, and that gives you the EV. So that's basically, EV is the expected value of what you would actually get if that does happen, because obviously you've got the probability of success being 0.2. well, then you're not guaranteed to get that amazing outcome that you should be getting in result there, right? And same, if your failure is like 0.8, then you're not going to get the terrible result. Those are the two extremes. So you're going to end up, you need the figure somewhere in the middle. Now the way that you do that is you just simply get result times probability equals EV, and then add the two of them together to give you the total EV. And you have to do that for both of your outcomes, for both of your options, sorry. All right, so once you've got the total EV for both of those, you can then work out the net gain. And net gain is the amount of money that each option should bring you, the expected amount. The way that you work this is you get your total EV and you just take away the cost all the way from the front there. So total EV minus cost equals net gain. And generally the rule is that the highest net gain is the one that wins. So if you have high net gain at option 1, you would take that. If it was high net gain at option 2, you would take that instead. Now that's just looking purely at figures. So it doesn't take into account any kind of other ideas. Whether there's funding, whether there's a time limit. It's just simply breaking everything down. Here are your options. Here's the money you're going to get from it. Which option you're going to take? You're going to take the one that's going to give you the most. Okay, so all of that's a little bit hard to remember, so we'll try it from a working example. Some of you might appreciate just sort of where the figures actually come from. So we've got here, the owner of a motorbike repair garage is planning on expanding the business. The options for them are to build a forecourt, to sell petrol to the locals, 20% chance of low demand, or to construct a new bike showroom to sell motorbikes, 80% of high demand. The cost of the petrol forecourt is estimated at $100,000, and the showroom will cost $150,000. In return, the return will depend on the level of demand in the market and economy. Use the table below to draw a decision tree on this question. So you can see that you've got a table, you've got high demand forecourt will return $550,000, showroom will return $800,000, low demand will return $400 and $200 respectively. Okay, so straight away we would start with that square. So you would draw the square. Then you go for your first option, which is the forecourt. Now from that, we know how much it's going to cost. It's going to cost $100,000, and then you can draw off your second line, which is your showroom, and the $150,000, which are the costs. Now, don't forget, put those into brackets because they are costs. Each one of those goes to its own options bracket then. So we go to the first node and we've got high demand. So actually use the wording in the question. So it's talking high demand, low demand, so make sure you use it. And the high demand is 0.8 because we can see that the forecourt, if it's low demand is 0.2, they both have to add up to 1. So therefore we've got 0.8. So add them together, you get 1. And that should be the same all the way. Now, if you get an extra node an extra outcome in there, so high, medium, and low, then again, all three of those should still just add up to 1. Then we've got the amounts, so start filling in the blanks. So the amounts, we've got high demand is 550, low demand 400,000, sorry. And then you do the same at the bottom. So we got the showroom high demand. So it does state high demand is 80% chance. So we convert it nice and easily, 0.8. Low demand is 0.2 because again they've got to add up to 1. And then we've got 800,000 and 200,000. Now once we've worked that out, we go on to the EV. Now again, keep it neat, right? You've already written 550,000. So why add up, why put equals 550,000 times 0.8? Don't do that, just go straight from what you've actually got. So 550,000 times 0.8, which is the probability. So we go from there to there, equals 440,000. Do the same for the bottom. So 0.2 times 400,000 equals 80,000. Then add them together and we get total EV for that particular option, for the forecourt option, is 520,000. So that's kind of more how much money you're actually expecting to make. because obviously, like, you know, the probabilities sort of add through, don't they? Right, then we do the same at the bottom, which gives us 680,000. And then from there, we need to work out the net gain. So don't forget, net gain equals total EV minus costs. Well, we've written total EV already. So all you have to do is just put in the minus the costs, gives us 420,000. So costs, don't forget, for the forecourt is 100,000. So 520,000 minus 100,000, 420,000. Then you do the same at the bottom, which gives us £530,000. So which one should we choose? We should absolutely choose the one that's going to give us the most amount of money. So therefore, the new showroom is going to give us £530,000 return compared to 420. So that would be the one that you actually go for. So key terms. Now we're looking at probability, which is the chance of an outcome actually happening. We've got the expected value. So make sure you're writing all these, by the way, folks. The financial value of an outcome calculated by multiplying the estimated financial effect of its probability. So how much money you're actually going to get times its probability. And then net gain is the value to be gained from taking a decision. So calculated by adding together the expected value of each outcome and taking away the costs associated with it. Now, they can get more complicated. I mean, like, if you go back, you can actually sometimes get another decision to be made, but you shouldn't be getting any of those in your exams. Okay, so why do we actually use decision trees? So there are advantages and disadvantages. So the advantages are that it sets the problem clearly and logically. You can actually look at it and go, right, okay, so, you know, if we do this, what will happen? If we do that, what will happen? It takes into consideration any alternatives, so you're not just going down like one route. I wouldn't recommend putting like 20 of these together, but you can actually look at like several options and compare them properly. It turns things into a quantitative approach, and it's very easy to computerize. So it takes an idea and turns it into actual numbers. Okay, so what is going to be that outcome? And of course, then if you can computerize it, if there are more complicated ones that need to be designed, then it will be able to do it for you. It takes into account like any kind of risks and rewards that you would get from it. So you can actually go, well, what are the probabilities? Am I going to get a good amount of money out of this? Am I not? And then finally, it's easy to actually understand the results. Right? You can read it and you can go, right, okay, well, that's got a high NG, so therefore we're going to go with that option. Disadvantages, though, is that it really ignores the constantly changing environment. I mean, like, you know, prices aren't going to stay the same, tastes aren't going to stay the same. You're not guaranteed to get this money or like the returns that you think you might. Probabilities are just estimates. They might not be realistic. So think about it. You know, you're saying, well, you know, it's an 80% chance of that. Well, how do you know it's 80%? You don't fully know. It's just really a guesstimate, right? And it ignores like the qualitative factors as well. So it ignores the fact that, like, again, tastes do change. That you know, if we go back to the working example, well, it ignores the change in like cars from petrol to electric, right? It doesn't take that into account. Well, obviously, over time, that should make an actual effect. Now, not necessarily over the short lifetime of a garage forecourt, but you never know. It's easy for management to be biased, so they can actually like say, well, we think it'll be 80%, when in reality, you know, it might only be a 50% chance of this happening, but they're really behind an idea, so they want to push through. And then also, new situations can be very hard to estimate. If you've never done something before, well, how can you get its probability? How do you know how much money is actually going to come back from it? You just really don't. Okay, thanks very much for watching, folks. So that is decision trees. For more information, like, make sure you hit like and subscribe to Flipping Heck Business so that we can you can gather more videos on what we've got. Feel free to leave any constructive criticism below in the comments. So if you don't like my voice, that's fine, but you do have to still listen to it. If there's any ideas or any like plans that you would like to see us like go over again, or if there's any questions as well, maybe I can help you with those. And then we have got the next video will be following very, very shortly. Right, bye.